So the webinar today about visualization of data from the eNanoMapper demonstration instance using JavaScript, the API, and d3.js will be given by me, Egon, and Nina, who's also on the call here. What I'm going to propose is that while I'll try to get my GoToMeeting working here so that I can actually show my slides from my screen, I will give the floor to Nina so that she can first talk about the API part of this presentation, discussing how in a machine-readable way, information from the eNanoMapper and eNanoMapper database instance can be retrieved. While she is doing that, I will send my slides to Spela. She can show my slides. Nina, are those your slides or are those my slides? Those are no, that's your slides. API overview. Okay.
Yes. Yes.
I was confused. It looks so much like my opening slide. So yeah, to introduce me and Nina. Nina will mostly introduce herself, I hope. I'm one of the from the Maastricht University partner in eNanoMapper, and we're a systems biology group. I've been using ontologies in my research for quite a while, including now here in eNanoMapper. My personal interest is data analysis, and visualization fits in there. And I now will give the floor to Nina.
Thank you, Egon. Welcome, everybody. I'm Nina Jeliazkova from a small consultancy company in Sofia, Bulgaria. In eNanoMapper, we're leading the database work package and develop the database prototype on the basis of open source project our company developed for 10 years already, but this is extension into the nanomaterials domain. So my presentation will give you some idea how the API is organized and how you could test it, and then Egon will show more fancy visualization based on the same API. Okay, so you probably have heard about the eNanoMapper prototype database through the various dissemination activity of the project. You could access it and data.eNanoMapper.net. And it's a web application with some user interface, but the user interface is actually using the application programming interface I will be talking about. There is a publication from last year which is cited here. So why do we need application programming interface for database? It's nice to have all the user interface with screens to go through, but if you want to retrieve this information and to do some meaningful analysis in it, we need programmatic access to the database. So these days, I'm quite happy that I don't need to define what application programming interface is, because web services so widely use it. So this is basically a common knowledge what web API is these days. But anyway, application programming interface or API is just the way the computer programs talk to one another, possibly through the network. This is basically how the programmers send instructions between a web server or some other program. Why do we define why API got such widely used? Because if you expose your service through some well-defined API, it makes it easier to develop a program by just using the components, the common components of your system, maybe gluing it with another system, just like putting the blocks together. And besides that, we can access the database via any programming language, incorporate some more complex workflows in workflow systems, and of course build user interface and nice visualizations. Another way to recognize why API is useful is that you could change your underlying database technology for, let's say, providing better performance or some other reasons, but we keep exposing the same API. This has happened with the big sites like Facebook and Twitter and so on quite several times. They change their underlying technology continuously, but they don't really break their API totally. They usually keep some core grounds. And from network engineering background, where I'm originally coming from, the API should be ideally have multiple independent interoperable implementation, which is something you usually see in the life sciences, but something in OpenTalks we tried to do a few years ago. To be more specific, we started eNanoMapper with the idea that we can reuse the OpenTalks API. OpenTalks was a project finished in 2011, and then the main focus was predicting predictive toxicology for chemical compounds. So we defined some common components like chemical compound and data set and model, and defined a way to describe a data set, which is basically a spreadsheet of data with some explicit annotation to how the column is defined, where it comes from, how it was calculated, and so on. And it worked quite nicely for machine learning purposes, but then in eNanoMapper we met quite different challenges of describing very diverse assay data, describing nanomaterial physicochemical identity per se, biological identity, supporting different kinds of data like images and raw experimental data, and the diverse requirement by different users, like regulatory would require some different slice of the database compared to the modeling community, and so on. So the spreadsheet data from OpenTalks was really less suitable than we thought it will be. And we had to tackle all these nanomaterial difficulties, being able to describe nanomaterials structure, components, linkage between them, different assays. There are a lot of existing attempts to describe all these components. This is described in several in a publication and in other documents from the project, so I will not go into detail why we describe in a certain way, but just will try to demonstrate how the API works. So the API is a web API, REST API, which stands for representative resource representative resource state transfer, and this is the most widely used type of the web API these days, and there are a lot of tools available around for visualization, documentation, libraries for working with this kind of API, and we're currently using the Swagger user interface for documenting the API, where we could see it through the following link. There is a link from the GitHub, eNanoMapper GitHub repository, and you could see that there is a mix of OpenTalks API, but also substance related related API, which is exactly what we're using for nanomaterials, because we consider nanomaterials special type of substance. We could find a lot of information about Swagger over the internet, and this is what we use for our documentation. So this is not complete overview of the API, but we just few representative pages. We can try to look for substances. So the Swagger interface for documentation looks like this. There is some brief description of the service of the particular call. Then there is a description of what the JSON response contains. On the structure of the JSON, then there is a drop box of describing how the content, what format the content would be returned, and then search parameter of the REST API. And at the bottom there is a button "Try it out," which means that when you try out, it actually sends a request to the server and gets the response. Here, for the sake of simplicity, I selected that the response is one line, just a list of URI. And when I'm searching for nanotube, it returns the URI of the nanomaterial, which is a nanotube. And this all the information returned this way could be arranged to create some nice user interface, like at the bottom of the slide. Of course, once we find the nanomaterial, we want to retrieve something about it, and then we have a call which we supply the ID of the material, and we can request experimental data by this call, which in this example I'm restricting it to FISCAM properties. Clicking try it out returns the results in JSON, and once we decide on some visualization, we can describe or can parse this JSON and generate some user interface. This is, I'll try to demonstrate this live. So FISCAM, and this describes how the return JSON will look like. And we click try it out, and we get a long reply with different with JSON describing different different studies, which let's examine this one. So we have eventually defining the UID of the substance, who is the submitter of this substance, then what type of measurement it is. We could have here some pointer to the protocols and various parameters, flags for reliability. If we have this in the database, we can have some kind of summary in the interpretation, and the measurements per se, like zeta potential right here with the value of 41.4 units, and the conditions, this is pH 1.9. And we might have different measurements under different pH in this case, and so on. So to continue with the examples, this is how the data is organized for all kinds of measurements. This is roughly described in the publication and the rationale for doing this. And besides getting the experimental data, we can use the chemical structure search, variety of chemical structure searches. What I'm demonstrating here is looking for titanium dioxide smalls, which represents the chemical structure. We can select the output formats. This variety of formats come from the OpenTalks API, and this is RDF semantic format for describing the result. And of course, once we receive the format, we can do something nice with it and do some visualization. Also, we can search them, we can find the nanomaterial per se given the chemical structure, because we might have a number of samples, a number of different materials related by the same chemical structure, containing it as a component, for example. So we have a separate call for searching nanomaterials by structure, and we specify the URI of the compound which we, let's say, found from the last slide. And once we specify the URI, we actually receive as a return a list of substances, which could be seen also on this visualization given the titanium dioxide, all of the entries in the database which contain this as a core. Or maybe if you look for some organic compound, we'll find it as a coating or so. And finally, the reverse operation, when we have a nanomaterial, we can look for its composition by the corresponding call, and receive again a URI of the chemical compound and different values. Of course, this could be visualized and also could be arranged in a different set of different visualization. And I think this is my last slide, and I hope Egon will have enough time to demonstrate what he has done with this API. Egon?
Okay. Yeah, I was trying to unmute myself, but I think Spela was doing the same thing at the same time. Nina, so while you were talking, I managed to log in with my laptop. Unfortunately, after some 5 minutes, my whole laptop decided to shut down because the CPU was getting overheated. So I'm going to try to log in once more, but meanwhile, I would like to ask you, can you please put up my slides on your screen?
Sure.
So what we have seen now is the API, the database of what eNanoMapper offers at this moment, and my part of this presentation will be about how we can use this. So one of the central parts of the eNanoMapper design is this API that Nina just showed. And this API can be used basically by any tool, by any client code that we like. And we're considering a number of environments where for which we want to develop plugins. For example, R could be such an environment, a workflow system like Gnome or so. But something that I was doing here as part of our education for a while was using JavaScript against databases. In particular, we were doing that visualizing data from the Open Facts database. Now, since both actually have a well-defined defined API, the step from one to the other, to eNanoMapper, was not that big. So I developed a small client library called ambit.js and started playing with that in combination with visualization. So I will say something about that. Before showing the next slides about some of the visualizations that you might want to do or might be interested in, the choice of JavaScript is somewhat deliberate. It's one of the key languages at this moment to develop applications, particular web interfaces that provide or that implement some process that we want to support by means of computers. That might be entering data, could be like that, or visualization of data, as in this example. And basically, there are these four needs in such a framework. So on one side, at the very bottom side, so to say, following these steps, we have the user that looks at the web browser and looks at some data there. So looking at that data requires some library to visualize data. We will see examples of that in a moment. And beneath that, there are a couple of layers that take us all the way down or all the way up to the data in eNanoMapper. But in between there are two components. One is the application programming interface, the API that gives us the access to the data, and in between there is a client library that knows how to talk to this API. So this presentation will focus particularly on step 3 and 4. And regarding step 1, the data, Nina already showed the data.eNanoMapper.net prototype demo instance of eNanoMapper, and that's the resource that I'm using here as well. Next slide, please. So d3.js is a JavaScript library, and this library has been developed to visualize data. And if you go to if you Google for d3.js, you will get a web page that looks a bit like that below. And those depictions there are all visualizations that you can do with this JavaScript library. And you do this basically by embedding a bit of code in a web page. The web page might be dynamically generated, it might be a static HTML page. It doesn't really matter, it's really the default JavaScript way of doing this. And we can have a look at the HTML in a moment. So there are many different kinds of visualization. So this kind of visualization is actually quite powerful, and this is how the students have been using it here in the course, is to use various ways of visualization to show the underlying patterns in data. And the same thing we would like to do here with data from eNanoMapper. And next slide, please. So basically, this slide, I'm not sure if you can make it full screen, Nina. There should probably be somewhere under view. But this is the database. Nina just showed it, and I'm using the API, so we actually can move to the next slide, I guess. Because Nina already showed this. So this client library, ambit.js. So ambit refers to the name of the software used by data.eNanoMapper.net. So the software developed by Nina's IDEAconsult that implements the eNanoMapper API. The software, like many of the components of eNanoMapper, are found on GitHub. You can find the link over here. The idea is based on the ops.js library developed in OpenFacts. Another thing is that it depends on jQuery. Now, anyone who has done a bit of programming in jQuery, in JavaScript, probably knows jQuery as one of the underlying libraries that makes interaction on the web a lot easier. And that is quite useful because what we'll see in a moment is that ambit.js is an asynchronous library. That means that when we make a query against eNanoMapper, we do not wait for the answer to return, but the JavaScript will actually continue. And it will use something that is called a callback function as soon that is being called as soon as the server, as the data.eNanoMapper.net, actually gives an answer. And we'll see that in action in a moment. Now, using an asynchronous API is actually not trivial, but it's not that hard. The students here, bachelor students here, can do that. The last thing that I probably want to say about ambit.js is that if you go to that GitHub project page, you'll find a README with a lot of information, and some of the next slides derive from that information. For example, so how we use this library together with the d3.js library is a web page. It's JavaScript. It runs in a web browser. So we use HTML as a glue. And what we will see in a moment when or Nina, for me, gives a live demo of some of the examples, is a web page. And we can have a look at the source code. But there are three principal things for the call here that are consistent with all the examples, and those are basically these three steps here. So we're going very technical here, and that is somewhat deliberate because we're talking about APIs here, and normally these kind of technical details, they will be hidden in a web page, but actually to make a web page like that, you do need to know those technical aspects. So first of all, I mean, we're dealing with libraries here, so we have to include the libraries. That is step one. Step two is an important one that points to an instance of eNanoMapper, and that is done in the bit of JavaScript code as shown there. It points to one of the API calls. Now, it sometimes is a bit hard to relate the call that we see in JavaScript with the API, and the documentation of the ambit.js library gives that a more detail. But what you might be able to guess from that line in step two is that this this object created here, this client code created here, is able to query the eNanoMapper API, specifically the substance corner. And the documentation of all those substance calls are available from the Swagger documentation that Nino showed earlier. Now, the third step is actually to make a call, to do a search. And if we look at the last line on this code, this is an actual call being made, and this list function that is being called there calls the API, the eNanoMapper API, and basically asks to return a list of all substances defined in this instance of eNanoMapper. So for the running instance, that should give in the order of 500 different nanomaterials, all with different properties. Now, you also see here this callback function that I mentioned, because if we look at this bit of code, the last line, that list call, when that is being called, it returns pretty much immediately. And in some future point, and we don't know when that it is, that depends on how busy the eNanoMapper instance is, but in some future point, the server will return a client. Will return an answer, and this answer is being picked up by the ambit.js library by virtues of the jQuery library, and then calls this callback function given here. And this function is then called with three parameters. It will indicate whether the call succeeded. It will have an HTTP status code, and in case that status code is something like HTTP code 200, meaning everything went fine, here is your answer, it will return a response. Now, the kind of responses that are possible were mentioned by Nina previously, and specifically in JavaScript, the use of JSON is very useful, and that is the default format that ambit.js uses. So to complete that this technical part of this HTML glue is that when this function actually is called, we can start doing something with the answer. The answer, the list, the JSON that represents this list of nanomaterials, we can do something with that. So one of the things that we might do, for example, is for each of the eNanoMapper each of the nanomaterials in the eNanoMapper database, we might ask for details, because the list doesn't have an extensive list of properties for those materials. So for some use cases, we might want to actually ask for each of those nanomaterials further information. And again, that will be calls to one of the many API methods defined by the eNanoMapper API. Next slide, please. So what we see here now is basically we have our web page that will use the client library that will call the eNanoMapper API that will look up data from the eNanoMapper database. So in that four-step thing, we're moving up, and then we're moving back again. The database will return an answer. The API will convert this to JSON. The JSON is received by the client library, and the HTML code then gets a JSON piece of information, which may very well look like something like the information shown here. So again, quite technical, but here we have the information we got from the API, and we can look up information here that we are interested in. For example, we might want to look at the citation information. Or we look at the bioassay data as shown in the protocol section. The JavaScript knows very well how to handle JSON, and extracting information from a blob of JSON is quite trivial. That is what JSON, the JavaScript object notation, that's what JSON is short for, is meant to do, and it does that pretty well. One last thing about JSON is that the visualization library, D3, does understand JSON, but we still have to indicate what information we actually want to visualize graphically. And that is perhaps the hardest bit of all these examples that we see in a moment. It is not actually using the ambit.js library. It's not making the calls that is hard, but it's actually telling d3.js what to visualize. And what I practically often do is take the JSON as we see here, extract the data from that, convert it into a new in a separate data model, and pass that to the visualization library. Next slide, please. So this is basically the last slide that I have before we move on to a live demo, where if people are interested, where we can actually have a look at the HTML code, is this list of examples. So if you go to this GitHub page that I mentioned earlier, and maybe someone with can type or copy paste the address in the chat window, which on a computer is handier than on an Android tablet. If you look at the README, there is a link there to this page that we see here. And that example page linked from that README on GitHub shows this list, and each of those examples here is a live demo. And what I'm hoping, Nina, is that you can open example 1, please. That probably it's a bitmap. Clicking will not work. But if you go to github.com/eNanoMapper/ambit.js, or replace, yeah.
Oops, not this one.
If you scroll down to the README, it's oh yeah, you also see here actually the top line now, also a link to the API documentation, but the example use. No, sorry, a bit up. Oh yeah, exactly. That link. The full examples are found here. No, sorry, you had the other one. You were right.
Is it this one?
Well, I can say, yeah, it's actually, so yeah, click substance there, please.
Okay.
So we'll wait with the live examples for a bit, and showing this documentation actually is useful as well. So in JavaScript, you are mostly working with the ambit.js library, and this documentation here indicates the various methods that are available. And each of these methods corresponds to one of the API methods in the Swagger documentation that Nino showed earlier. And I realized that I haven't added the equivalences here between the Swagger API, so the real API, and the JavaScript calls that you can make here. I will fix that as soon as possible. You can also see here that at this moment I have two parts of the eNanoMapper API implemented at this moment, which is substance and bundle, and that already gives me quite a bit of functionality. But all the other parts of the eNanoMapper API will follow soon. Yes, Nina, if you can please open the examples now. Yep. So if you can show example 1, for example. So what we see here now is we started with a pretty empty page, and it's, after, I don't know, a fraction of a second, we started to see the JSON. The JSON was actually dynamically requested from the eNanoMapper demo instance server. It basically asks for a list of all nanomaterials, and as you can see, now that Nina is scrolling through this file, we see a long list, a repetitive list of a short description of the nanomaterials, and for this list of nanomaterials gives for each material a URI, intrinsic bit of information in the semantic web, identifying the material. We see some information about the owner or the originator from this data set. We see a name for that material, or sometimes even two names. There's a bit of substance information. Some materials even have external identifiers, as we can see here now, or a composition, but not always all the information, and particularly the assay information, is missing here. But this example, and Nina, maybe you can just show the source of this page as well, just as a quick demonstration. If you scroll down a bit, then this is actually all the code that there is to this example. So this is all the code that is needed to get information from the eNanoMapper instance. And what we see here at line 37, 38, we see the loading of the libraries along with the jQuery library in line 32. The Perl.js is a dependency of jQuery. But the code to make this to retrieve this list of materials is just what is given between line 46 and 53, and particularly indeed line 53 makes the call, and then at some point, a fraction of a second later, after loading the HTML page, we see the content. And what I said at first, we start with a pretty empty page. Some of you might actually have seen that it says nothing yet, and we can see this on line 44. over there. Yes, thank you. And when the callback function actually is called in line 51, it will overwrite the HTML of that web page and will replace the text "nothing yet" with a stringified version of the JavaScript object. That's the bit of code doing in line 51. Yeah, thank you. Can you go back to the list of examples? Can you, show this example? So again, we saw the slight delay in actually showing the graph. So this graph that we see here now is generated live from the data. So as soon as a new data set comes in, this diagram, by reloading this web page, will be updated. And you can look at the HTML source of this one as well, and we'll see it's a bit more elaborate. It's still not very long, but what we see here is mostly code that actually does this conversion of the JSON that we get from the eNanoMapper API into a data model that the D3 understands. And some code that starts around line 84 until 126. That is all code that tells D3 what kind of visualization to make. Now, I didn't make up this code here. You actually copy paste that from the D3 website. And what I haven't played with yet is that there are also a couple of libraries that extend D3 or that wrap around D3 that actually remove the need for this manual definition of how a pie chart should be generated. The second thing that I want to mention here is that on line 123, we have again this call. 123, yes. Again, this call to list the materials, but we also saw that that may not be enough. And if we scroll up, we see the callback function again here, starting at line 50. This pie chart example still depends on a single API call. That will differ now if we go to the next example. So we now go to example 4, please. Sorry, the next is just another, example 3 is just another pie chart. Okay, here we actually see JSON, but we see a lot more information about the material. And this information is what we're going to use. And now we saw JSON, that JSON actually pretty much like one of the examples that Nina showed. This has information about the protocols. It might have information about the bioassays and so on and so on. And can you go to, and particularly at the end, the effects, where we see the endpoint particle size. And that's what we're going to use in example 5. So if you please show example 5. So what we see here now is two things. First of all, notice the thing that is set between the header enum sizes and the header JSON reply. Nina, can you perhaps reload it so everyone can have a look at that? It says there between those things something still to load. And that's the asynchronous aspect here. So we got our list of materials, but for each of those, and I'm asking here just for the materials from the NanoWiki dataset, for each of the 350 materials in this dataset, it will make a second call. So in total, it makes an equal number of calls as there are nanomaterials in this dataset plus the initial list set. And it will do this asynchronously, so it will have to keep track of how many information it already loaded, and that's what basically the line was reflecting. And at the point where there is no further information left to download from eNanoMapper, if there is no further API call to be made, then it can start aggregate this information, or it does it actually on the fly, and then it can create a plot like this. And in this case, it gives an histogram of the nanoparticle sizes reported for those all those materials in the NanoWiki. We can do that for the E&M sizes. We can also do that for the zeta potential, and that should be example 6, I think. We see the same kind of thing. It loads all those materials one by one, and then we get a plot like this. Now these are quite simple plots, just summarizing data in a particular data set, for example, which might be one of the use cases here. If you, and we're not going to look at the HTML source here, but if you actually look at this HTML source, you will see how this asynchronous thing works. So we actually get 2 callback functions now. One callback function that handles the JSON returned by the list call, and the second callback function that will handle the JSON that is returned by the call that asks for additional information. Well, if we're looking at it anyway, so if you look at line 171, that bit there, that is the callback function, as we can see in line 183, that handles the JSON returned by the list command, or by the list call. And you can see by the for iteration here that for each substance it will make a second call on line 177. There it asks for each material, it asks for the additional information, and that is handled indeed by the process size callback function. And that is pretty nasty code. It will extract the zeta potential. It puts it in a temporary a global variable, and at the end of that callback function at line 188 it will see if it has still more workload to do, and if it doesn't, then it starts calling the plot function, which is given earlier. So we have callback functions that make additional calls, so this can get very complex, and the students typically have, well, when they did this for OpenFacts, they had callback functions which triggered callback functions, which triggered callback functions, which triggered callback function. Keeping track of all that is quite a challenge, but the advantage is that it does make the web page quite responsive. Can you show the next example? Let's see, what is that? Oh yeah. So example 7 is an example that does a search. So we're now this web page is actually searching for nanomaterials in the database. So the first few examples, they gave a summary of a particular data set. So we can just ask for all the materials in the data set. But we can also use the search API that Nina mentioned. What we do in particular here is search for all nanomaterials in this database that originate in a paper from the Maastricht Journal of Nanotechnology. And at this moment, this NanoWiki dataset only has one paper from which nanomaterials were extracted, and as you can see, the percentage of viable cells was given for that. Yeah, I was a bit distracted because Nina scrolled down to the JSON, so I was looking at the value. And if you can you scroll down a bit, Nina? So normally we would have in the protocol section here, about a bit halfway down this page, we see the percentage of viable cells. We also see the bioassay ontology annotation there in category. So that is a preliminary view of the semantics, the semantic integration, the ontology integration in the database. Nina, please show the next example. That is again a search, in this case for ACS journals, so this is not journals from one specific journal, but from all the journals from the American Chemical Society. And so we see journals like Nanoletters, ACS Nano, JAX, and a few more. And we see the various endpoints given here. So this is an example of one potential use case there where we might go to. So all materials from a particular journal or from a particular publisher we can actually summarize, and this is just giving a list of materials, but we can make the pie charts or the histograms or any of the other D3 visualizations that we had on that slide from the D3 website. We can do that via this API. And here too, the HTML code is not simple, it's not trivial. But as you can see at the size here, look at the scroll bar. This is just 100 lines or so. So it's not complicated. Can you move to the next slide? Yeah, I'll skip how the search actually is done. Yeah, best to go to the last example here. The same pattern as we saw with the histograms again, but this is just another kind of visualization that I'm actually interested in starting to use. Because this basically allows a live version of figures in research papers. So rather than having a bitmap or perhaps an SVG or a figure outlining some of the things, what I'm going to try to see if we can get some examples going with publishers to have figures from papers depicted in this way, using a library like D3 and extracting the data from a data resource where the information is available in a machine readable way, and therefore can be included in data analysis workflows. This particular scatter plot is probably not the most interesting one, but shows the zeta potential for materials in the NanoWiki data set in the x-axis plotted as a function of the size of those nanomaterials. We don't see any pattern here, and that has many reasons. I didn't expect it here, so more interesting, but that's a use case. That is an example, a bit of code that I didn't manage to write up before this presentation, is to plot zeta potentials as a function of the pH at which it was measured. But obviously, I mean, if we can do a scatter plot, we can basically plot anything, and we can plot any relation that we might might want to test or just want to have a look at from any kind of nano QSAR-like paper we are interested in. So that basically wraps up what I wanted to show everyone about this integration, this data visualization using the eNanoMapper API. And I'm welcoming questions, and I guess to both me and Nina.
Hello, Egon. This is Fred Classic. Very nice presentation from both you and Nina. And I thank you very much for the time and effort. My question is going to be on the granularity and the details. For example, one can measure zeta potential over a large pH range and get many different answers. So when you put a chart up that has zeta potential and particle size, the question comes up, are they all measured the same pH, or they, etc. So I'm assuming right now in your presentation that this is general catching of data, but not necessarily granular in the sense of standardized and so forth. Am I correct there?
Yeah, that's correct. So the NanoWiki data that I worked on myself is extracted from literature. So you're very much dependent on what information is available from the literature. The data that Nina is now showing on the screen shows a nanomaterial where indeed they actually measured the zeta potential at multiple pHs, all acidic environment by the looks of it. But you see this this dependency. I'm a bit surprised by the results here, because what you typically indeed see is that you see a sigmoid-like behavior for nanomaterials depending on the pH, which doesn't entirely seem to be the case here. But yeah, you're absolutely true, and that might actually, I mean, that's a use case that we have been discussing. So visualizing data from a paper, it could be getting data together for that you might want to have as part of a publication later on. So one possible use case that we have been discussing and might implement is to actually aggregate information in an eNanoMapper instance that might be local, it might be just on your laptop. Aggregate that information with a GUI to enter it, and then have a number of these standard plots that will automatically be generated then, that allow the user that is doing all these measurements to actually look at that data and to see if there are things that they would not have expected. So I'm hoping that what we think is that these kind of APIs will actually help support getting all the right information together.
Thank you.
Anyone else with questions? Stacy, are you on the sound as well? Because I would have a question for you.
Yeah, go ahead.
Yeah. Okay, cool. So having seen these examples and the HTML code that is needed for that, in your current impression, do you think it would it is easy enough to integrate that into existing web interfaces?
Oh, see, I'm not the right person to ask that. I'm not really the technical expert in this area at all, so I don't think I can give you a good answer.
Okay.
Egon, this is Dennis at CAIN, and I just wanted to chime in on that question, because I work at the UCLA Nanomaterial repository doing primarily the same thing for data that our researchers measure. So for me, because I've been doing sort of the same thing, the method that you have using ambit.js and d3.js makes it very, very easy to integrate the visualization and the JSON record set into another website. I think if you, like you were saying, if you have some experience working with HTML and JavaScript, then it wouldn't be difficult. I think this method is makes it fairly quick. Although I think my only issue is that most of the people who probably would be wanting to extract the data wouldn't be as technical as I am. So I don't feel like I'm a good representative of someone who would be the end user of the data in eNanoMapper. And this is sort of like the same challenge we have with our system, because it's stored in an organized way, but pulling it out requires some sort of knowledge on the technical aspects also, whether it's in codes that are available in GitHub or some SQL related queries. So yeah, so I guess my answer is yes, it's very easy, but you kind of have some sort of prerequisite skills before.
No, that's absolutely correct. What Marlene and I indicated is the importance of these APIs. So we have a stacked set of technologies on top of each other. We're developing underlying technologies like this, which are aimed at people, at bioinformaticians basically, and perhaps not even all bioinformaticians. And on top of that, we're developing other solutions that do not require any technical knowledge. But we believe that we need to have both of them because those who want to do data analysis, they want to have access to the data from their preferred data analysis platform. Those users will be technical, and those users we will guide with client libraries like ambit.js here to give access to the data. But it's a different kind of user, different persona, as those are often called, than the user from which you want to hide all the technical aspects.
Yeah.
And we do both in eNanoMapper.
I see. No, thank you. This is very helpful to see.
Okay, if there are no further questions, thank you very much for joining, and thank you for all with your questions and interest. And if later new questions come up, or when you discuss this with others and questions come up, please feel free to contact us and to ask details.
Thank you very much, Egon and Nina.
Thank you.
Goodbye.
Bye, everyone.